Hey everyone. Clearly when I made my limits video, I was in a rush not thinking because I gave you a limit equaling 0 kind of for free without explaining why. Um, so I'm going back to that polar example where we were trying to bound our function r sine theta ln of r squared. And this idea of if you're plugging in something for r, leaves theta open even though sine is bounded. And I never really explained that when you approach 0 from above for r, we get this idea of 0 times, and if you can think about the graph of the natural log of r squared, just from above 0, we're approaching negative infinity. And of course, if you haven't thought about this in a while, you might gloss over and be like, okay, 0, but that's not the right thinking. This is one of our indeterminate forms, if you don't recall. So with these indeterminate forms, we like to rewrite them as either 0 over 0 or infinity over infinity, so we can't apply L'Hopital's rule. You might ask, well, I thought you said we weren't allowed to use L'Hopital's, but we've turned this multivariable equation into an equation of one variable. In equations with one variable, you can use L'Hopital. So how do we take something of the form 0 times infinity and turn it into one of our indeterminate forms so we can use L'Hopital's rule? We often take one of them and put it in the denominator as 1 over that function. The easiest way to do that in this case is going to be putting r in the denominator. So multiplying by r is the same thing as dividing by 1 over r. Now if you think about the limit of the numerator and the denominator separately, that's going to go to negative infinity, that's going to go to infinity. There's one of our indeterminate forms. Now we can use L'Hopital's rule. So we take the the derivative of the top, which is 1 over r squared times 2r over negative 1 over r squared, which is the limit as r approaches 0 from above of 2 over r over negative 1 over r squared, which we can rewrite as limit as r approaches 0 from above of 2 over r times negative r squared, which one more time, limit as r approaches 0 from above of negative 2r, which then equals 0. So again, apologies for kind of just glossing over that in the video. That is not something that we just know off the top of our heads, and it's way more complicated than I made it appear to be. So sorry about that. Have a good weekend.